Let's look at the following question. The problem states, fill in the 6 boxes with distinct integers 1 to 5 so that the following equation holds true. And the equation goes box plus box minus box times box divided by another box equals 6. And each box represents a distinct integer. There are 5 boxes, and there are 5 different integers, 1, 2, 3, 4, 5. So each box is going to hold a different integer. Please allow yourself several minutes. Try to solve this question yourself. Assume that you spend the time already and you understand the question clearly. So what's your approach? At first look, it appears to be that really there are not so clear way to solve this question. But actually the key here is this part. A digit times a digit divided by another digit. Now why this is a key? This is a key because the first two are integers, add up to be integers. So this thing has to be an integer as well. Right? And this integer is not going to be likely 1. Actually, if you think about 1, 2, 3, 4, 5, you actually don't have two numbers multiplied together equals the other integer. Okay? So this is an integer, and it's not going to be 1. So this integer is going to be at least 2. Agree with me? Now, because this is at least 2, so this adds this is going to be at least 8 to make this plus this minus this thing equals 6. Correct? Because this, if it's 2, then this adds up to be 8. If it's 3, this adds up has to be 9. But look at these numbers, 1, 2, 3, 4, 5. What is the maximum sum you can have by adding these two digits? You see clearly, only maximum is 9. This adds this. The first two things add up. It will be less than equal to 9. So now you have two things. This is at most 9, and this is at least 2 to get it 6. Well, you see, so this thing has to be at least 8. All right, for the two boxes, the first two boxes add up, has to be at least 8 and at most 9. So now you have the key constraint here. So these two things only can be, the first two digits only can add up to be either 9 or 8. All right, so we have two cases we're going to try and error. If the first two boxes add up to be 9, that means the first two boxes are going to be, this can be 5 or 4, does not matter. The ordering does not really matter. 5 plus 4 minus another 3 boxes we don't know yet, but we know that the first box times the second box divided by another box equals 6. And we know the digits possible here are 1, 2, 3. Is this possible? There's no way to make this one equals a 3 by using 1, 2, 3 fill into these boxes. Right? The 3 cannot go here. If the 3 go here and this has to be 1 times 2, this is not even an integer. Okay, that's what we start with. This has to be an integer. If the 3 goes here, then if the 2 goes here, this becomes a 6. If 3 and 1 goes here, 1 times 3 divided by 2 is not even an integer. So this cannot be possible. The second case is the first two boxes going to be add up to be 8. So, and that's the only choice you can have is 5 plus 3. minus something times something divided by another thing equals 6. So that means you have 1, 2, 4 left going to these 3 boxes. And these 3 boxes, you have to make an equation equals 2, because the first 2 boxes add up to be 8. These 3 boxes has to make it 2. So how you can make that possible? Well, in here, it's pretty simple. You see that how you make a 2. The 4 cannot go there, right? 1 times 2 divided by 4 is not an integer. So 4 has to go somewhere here. And then with that, 2 cannot go there. 2 has to go there. And 1 goes there. So 1 times 4 divided by 2 equals 2. And so we have the solution. Here goes a 5. Here goes a 3. Here goes a 1. Here goes 4. And here goes 2. 5 plus 3 minus 1 times 4 divided by 2 equals 6. So we have the solution to this question. A bit of review of this problem is the key of this is you're figuring out this multiply and divide has to be an integer. Now, actually, we can expand a little bit. When this is the integer and you have the digits 1, 2, 3, 4, 5, right? Which this digit can be, actually. Can it be a 5? It cannot be, because no 2 integers times together divide by 5. You don't have any other factors of 5 here, so divide by 5 never can be an integer. Can this digit be a 4? Cannot, because the other 4 numbers multiplied together is not a multiple of 4, so this digit cannot be 4 either. Can it be 3? By the same token, cannot be 5. It cannot be 3 either, because the other 4 digits is not a multiple of 3. So this digit only can be 1 or 2. And I'm going to say that even 1 is impossible. Why is that? If you put a 1 there, these 2 digits multiplied together has to be at least 2 times 3, which is 6. So this thing, if this box is a 1, these 3 things, this box times this box divided by 1, is going to be at least 6. But then you have first 2 digits has to be added up to be at least 12. Impossible. So by this simple derivation, logic thinking, this digit has to be a 2. So you can actually have this step pretty clear. This is going to be divided by 2 equals 6. This digit we can actually derive by using this logical derivation. And with that, you know this digit has to be a 4, because without a 4, you cannot have this thing multiplied together equals a 2. So this has to be a 4. With a 4, can you have a number other than a 1? If you have at least a 3 there, this is at least 6, and impossible. You have to be a 1, and you have to have 5 and a 3, and this satisfied. Okay, this actually gives a second approach to solve this question. But again, the key of this question is this multiply this divided by this is an integer. And it also had this constraint, this integer cannot be too large, because this 2 numbers add up is not too big, so this number cannot be big either. All right? And that's for this question.